problem number 1 for the operation of vectors. Given here are the vectors A, B, and C. So for vector A, we have 8i plus 4j minus 2k pounds. And for the vector B, that is equal to 2j plus 6k foot. And for the vector C, that is 3i minus 2j plus 4k foot. Calculate the following for A, that is, for A, we are asked to find the dot product of A and B. For B, the orthogonal component of B in the direction of C. And for C, that is the angle between A and C. And for D, the cross product between A and B. And E, the unit vector lambda that is perpendicular to both A and B. So let's start with A. So A, we are asked to compute for the dot product of the vector A and the vector B. So for the formula, no, we have the dot product as the AX BX plus the AY BY plus the AZ BZ. Okay, tingnan natin ha. So, I, J, K. Kukunin natin yung mga coefficients niya. So, for vector A, that's 8, 4, and negative 2. For B, since wala tayong I, so that's 0. And the J is 2, and the K is 6. And for C, that's 3, and I and J is negative 2, and K is positive 4. So, that's for A, that's 8 times 0, no? So, since AX is 8, so that's 8 times 0 plus AYBY. So, plus AYBY. So, AY natin ay ito, BY natin ay ito. So, we have here AY is 4 and the BY is 2. Plus AZ is negative 2 and the BZ is 6. So, computing for this, we would have the dot product of A B, that's 0, this is 8, and this is negative 12, so 8 minus 12 is negative 4, so we have here negative 4. For the unit for A is pound, and the unit for B is foot, so we have here pound foot. So what does the negative indicates? So this negative here indicates that the angle between A and B is greater than 90 degrees. That's why negative yung nakuha natin dito. And this is the answer for the dot product for item A. For B, we are asked to compute for the orthogonal components of B in the direction of C. So, if we are going to let theta as the angle between B and C, then we obtain that B cosine theta is just equal to the vector B multiplied by lambda C. And from the previous lesson, we know that the lambda C is just the vector C divided by its magnitude. So we would have here the vector B. For the vector B, that's 2j 6k. So we have 2j plus 6k. Take the dot product of the vector C, that's 3i minus 2j plus 4k over its magnitude. So for the magnitude, it is just equal to this 3 squared plus the coefficient of j, that's negative 2 squared, plus 4 squared. Of the numerator, we would have here, since wala tayong I na nakikita dito, then that is equal to 0, and the I here is 3, and for the j, so that's 2, and the j here is negative 2, and we have here k is 6, and the k here is 4. And for the denominator, if we are going to compute for that, so we have here 3 squared plus, since the negative 2 square and the positive 2 square is just the same, so I'm just going to make this the positive 2 square plus 4 square. And we have here the square root of 29. So for the denominator, we have here square root of 29. And for the unit for vector b is in feet, and for this vector c here is in feet over for the magnitude of the vector c is in feet also. So canceling this out, we have the final answer, which is in feet. Okay, so computing for this, and we have here for the numerator, that's 0 times 3 is 0, of course. That's negative 2 times 2, negative 2 times 2, so that's negative 4, plus 6 times 4, that's 24, over the square root of 29. And we have here 3.71. So we have here 3.71 feet. And this is our answer for the orthogonal components of B in the direction of the vector C. For the third question, we are asked to compute for the angle between the vector A and C. So we let the angle alpha be the angle between A and C. And for this, we have the cosine of alpha is just equal to the lambda A dot lambda C. And for the lambda A, that is just equal to the vector A over the magnitude of the vector A dot vector C over the magnitude of the vector C. So we have here for the vector A, ito yung vector A natin, so that's 8i plus 4j minus 2k over yung magnitude niya, so that's 8 squared plus 4 squared minus 2 squared. Take dot product between c, and c is 3i minus 2j plus 4k, and the magnitude of this is 3 square minus 2 square plus 4 square. So computing for this, we have the cosine of alpha is equal to the dot product. We have 8 times 3, then 4 times 2, that's 4 times negative 2 rather, and minus 2 times 4. And for the magnitude of A, we are going to compute for this, plus 2 squared, and that is just equal to 2 square root of 21. So we have here 2 square root of 21, and this is square root of 29, yun na-solve natin kanina. So computing for this, and we have 8 times 3 plus 4 times negative 2 minus 2 times 4 over 2 square root of 21 times square root of 29. And we have here 0.16209. So 0.16209. And solving for the value of the angle alpha, we just have the arc cosine of our answer. And that is equal to 80.7 degrees. So we have here 80.7 degrees. And this 80.7 degrees here is the angle between the vector A and C. And this is our answer for item C. And for the problem D, we are asked to compute for the cross product of the vector A and the vector B. So for the cross product, we have vector A cross vector B is equal to, so we have the I, the A for, so in here we have the AX, the BX, and for J we have the AY and the BY, and for K we have the AZ and the BZ. So we have here I for the AX, that is 8. So we have here 8. And for J, we have here 4. For K, we have here -2. And for the vector B, we have 0 for I. We have +2 for J. And we have +6 for K. Now using the idea of using here the idea of the determinant, we have to copy the first and the second column, and that is I 8 0, and we have here J 4 and 2. So next we will be doing the cross up and the cross down. So for the cross down, we have here 4 times 6 times I, so that's 24I. And for this, we have 0. And for this, we have 16K. So plus 16K. And for the cross up, we have here 2 times -2, that's -4. So this is -4I. And this one, we have 0. And for this one, we have 6 times 8, so that's +48J. And we have here for the cross down, so that's 24I plus 16K minus cross up, so that's -4I plus 48J. So simplifying this, and we have here 24I plus 16K, so negative times -4, so that's +4I minus 48J. So for the final answer, we have here the cross product of vector A and the vector B is equal to 24 plus 4, so that's 28I minus 48J plus 16K. For the unit, since A is pound and B is foot, so we have here the unit of pound foot. So this is the final answer for the cross product of the vector A and the vector B. What if we are going to make use of expansion by minors? So we'll be using this first row here, and that would be plus minus plus. So for I, so that is I, since I is in the first column, so we will be using this for 2, negative 2, and 6. So we have here 4, negative 2, 2, and 6. And for the j, so that's negative, j is in the second column. So since j is in the second column, so we will be using this 8, 0, negative 2, and 6. So we have here 8, 0, negative 2, and 6. And we have here plus k. So since tatama and k yung third column, then we are going to consider 8 for 0. So we have here 8, 4, 0. Then we do the cross down and the cross up. So we have here 4 times 6 is 24. 2 times negative 2 is 9. 8 times 6 is 48. 0 times negative 2 is 0. 8 times 2 is 16, and 0 times 4 is 0. Then we have here cross down, that's 24, minus the cross up, that's negative 4, multiplied by I, minus 48j, since 0 and cross up, plus k, since 0 then you cross up. And simplifying this, we would have 28i minus 48j plus 16k. The unit is pi. And this is the cross product of the vectors A and B. So this is our final answer for the cross product of the vector A and the vector B. And for the last question, we are asked to find the unit vector perpendicular to vector A and the vector B. So with this, we will be using the cross product of the vector A and the vector B and divide it by its magnitude. So we would have here the cross product of the vectors A and B being the vector perpendicular to vector A and B divided by the magnitude of the cross product between the vector A and B. So what we are going to do here is just copy from our previous answer. We have the cross product of the vector A and B, which is equal to 28i minus 48j plus 16k. And for the magnitude, that is just equal to the square root of 28 squared plus negative 48 squared plus 16 squared. And computing for this, since we are just going to divide each component here in the numerator by the denominator, so papalitan lang natin ng x in numerator over the denominator, which is the square root of 28 squared plus 48 squared plus 16 squared. And then we are just going to substitute here in our equation using the calc function. So for I calc 28, that is 0.484. So we have here 0.48 for I. And for the j, we have calc negative 48. And we have here negative 0.83. So we have here minus 0.83j. And for the last, calc 16. And that is 0.277k. So we have here plus 0.277k. So this is now the value of the unit vector perpendicular to A and B. The negative of this vector is also perpendicular to both A and B. So we have here the positive and the negative of this value as perpendicular to our vector A and B. And this is our final answer. What if we are going to make use of the calculator in order for us to solve for this? So for the calculator techniques for computing the vector, what we are going to do is to set our calculator in vector mode, so that's mode 8. And we are going to enter the values of the vectors here. So for vector A, so press 1. And for the dimension, so as we can see here, this is 3. So we have here for the vector A, that's 8i, 4j, and negative 2k. And in order for us to enter the vector B, so shift and vector, that's 5. And we are going to go with the dimension, so 1. And let's proceed with the vector B, so that's 2. And the dimension of the vector B, so that's 3. So for B, the I is 0, and we have here 2 for the J and 6 for the K. And again, shift vectors, that's 5 dimension, and let's enter vector C, so that's 3. And that's 1 here. So we have here 3i minus 2j plus 4k. Okay, so for the operation for the problem A, we are asked to compute for the dot product of the vector A and the vector B. So we have shift for the vector A, so that's 5. Our vector A is number 3 here, so that's 3. Dot product, so shift vector, dot product is 7. And shift vector, since you are going to multiply that with the vector B, and the vector B is a number 4. So we have here negative 4. As we can see here, our answer for the dot product of A and B is negative 4. Okay, for letter B, so what if we are asked to compute for the magnitude of the vector C? This part here, no? The magnitude of the vector C. For the magnitude of the vector, so what we are going to select here is shift, height, and select the vector. So since C yung gusto natin kunan ng magnitude, so we have shift mode, the vector C is in 5. And we have here 5.385. And that 5.385 is this. No? Okay, so sasagutin natin ito yung problem na to. Ang hinahanap natin dito is the dot product of the B and the C divided by its magnitude. No? So for the vector B, we have shift mode vector B, that's 4. And dot product, so we have shift dot product 7. And then vector C, so we have shift vector C is 5 divided by the magnitude. So since the magnitude of the vector C is height, so shift height, select vector C. Vector C is 5. And we have here 3.71. And the 3.71 is our answer. Now, in solving for the angle between the vector A and the vector C, so ito lang naman yung formula natin. It's the vector A divided by its magnitude, dot product of the vector C and its magnitude. So, enter muna natin. We have to enclose this in parentheses. No? Shift vector A is 3, then divided by the magnitude of the vector A. So that's shift height, select vector A. Vector A is 3. And then we have that product. So shift vector dot is 7. And parentheses again. And dito na tayo kay vector C over its magnitude. So for the vector C, so shift vector C is 5 divided by the magnitude, so shift height. Select natin yung vector C, that's 5. And we have here 0.162, yung nakuha natin na ito pa lang yan. No? So, solving for the value of the alpha, we have shift our cosine of the answer. And we have 80.67 or 80.7. So, ito yon yung angle na nakuha natin. How about the cross product of A and B? So, for the cross product of A and B, we just have the shift vector. The vector A is 3, cross, so that's times, shift vector, the vector B is 4. And we have here 28i minus 48j plus 16k. And ito yung sagot natin. So, ganun lang siya kadali using the calculator. And explore na natin, no? Dito sa problem natin, what if we are asked to find the sum of the vector A and B? So, kung gusto natin kunin yung sum ng vector A and B, so that's shift vector, the vector A is 3, and plus the vector B is 4. So, yan lang, no? So, that's 8i plus 6j plus 4k. Ganyan siya kadali, no? And, how about the scalar multiplication? Kunwari, yung hinahanap sa atin is 2a plus 3b plus 4c. Yan lang. No? So, yung gagawin lang natin is, we just have the 2, the vector A is 3 plus 3, the vector B is 4 plus 4, the vector C is 5. And we have here 28i plus 6j plus 30k. No? So, ganun lang siya kadali. using the calculator.